So let us start with electric field due to a dipole. Here the dipole will mean electric dipole at an axial point. Electric field due to a dipole and an axial point. This dipole is nothing but electric dipole. As you have learned, an electric dipole will consist of positive and negative charges. That means equal and opposite charges separated by certain distance. So for sake of simplicity, let minus q be here and plus q be here. Then let this point where minus q is there, let that be E, A, let this be V. Let the midpoint be named as O. And if this dipole length is twice A, then half of this length will be A, half of the other one will be A. That's why we took the dipole length to be twice A. Then axial point means you will extend the length of the dipole like this, and you will take the point P to be somewhere here. So this point P, when you extend on either side, either on the left side or the right side, this point P will be termed as axial point. Point P will be axial point. Then if the distance from O to A, O to P, this point is taken as x, then how much should be the distance from P to A? P begin A phao se kya hoya ni adudi then si phao x am lai rahe, then si phao A am lai rahe, then PA should be how much? X plus A. Okay, distance from P to O, x hoya rahe, O to A hoya rahe, then total distance from P to A should be how much? X plus A. Then obviously this PB will be how much then? PB sina kya hoya ni? Then si phao x hoya rahe, si matek sina A hoya rahe, adudi matek se minus tawraga, this should be x minus A. X minus A. Why we need to find this PA and PB? Because by definition of your electric field, by expression of electric field, as you know, it is equal to K Q divided by R square. That means when you have the charge Q at a distance R, if you want to find electric field, then electric field is like this. So if you want to find the electric field due to the dipole, then you should find electric field due to plus Q as well as minus Q separately. Then let us try to find electric field due to the charge plus Q. Charge, let us forget about this minus Q. Minus Q se ngatang laite na khalo. You will have only plus Q, and this will be E1 vector. By definition of electric field line, it should be going away from plus Q. R square is the PB square when lower. PB square is x minus A whole square. Aduna x minus A whole square. This will be directed towards the right side. Similarly, if you find electric field due to minus Q hoy targadi distance square of kailawni PA square lord. So this one E2 will be directed towards left side. Why? By definition of electric field line, it should be directed towards negative charge. Then my magnitude to K Q P then PA square x plus A whole square line. X plus A whole square. Then in order to find the resultant electric field puthoke haiba taragadi kaidau tare amana right side tani amana left side tani, then there should be subtraction. subtraction of the vectors. To find the resultant of E1 and E2 vectors, you should subtract E1 minus E2. Okay, aduna now the net electric field, net highly effective highway, net electric field at point P is E equal to E1 minus E2, E1 minus E2, or magnitude of E1 minus magnitude of E2. Then masai E1 di electric field due to positive charge mangone hena nakpanina E1 should be larger, then minus Q cd P dagi hena lapanina electric field should be lesser. Aduna asida mai value hapjala singa sai gi do K Q divided by E1 gi dinga sai PV ni sin agri do PV di kya tare x minus a whole square. E2 di kya tare K Q x plus a whole square. Then koi kai do ya re dui ta agadi kai common low ya K Q common low ya re, then this should be x minus a whole square makada x plus a whole square. Then LCM the row, subtract the row, x plus a whole square minus x minus a whole square. See how land. Common log to LCM the row, subtraction the row. Then simplify the row, see? Simplify the row, line and tarani. Kari the row to the makagi a plus b, a minus b form the layer. Equal to, so they give some kandala, say k q. Kailangan makada di a plus b, a minus b di kaino a square minus b square ni x square minus a square. Adagi a plus b whole square expansion toro, a plus b whole square expansion toro di x square plus a square plus twice ax. Adagi minus layer, aroga a minus b whole square expansion toro ta agadi x square minus a square plus twice ax ta. Adu di x square cancel, a square cancel tore. Adu di kya tarani k c whole square lega dauni upon the square duga k q laire makada x square minus a square gi whole square laire ni. Then mathakta kai laire 4 twice ax to 4ax tare 4ax natra 4ax laire ni na asigi 4ax left side say muthalage 4ax ekoi semdoksi ramai semdokani haiba kanda sumaina twice 2 ama thangdo si twice k ama le si aduga kari lem hore twice ax ima tongana thamba yare adu ta gadi makhala kai lem awi x square minus a square whole square le sigi matagi numerator doesn't change now. Anuna twice a q x ni twice a q x ni like say twice a q di koi kari ka mana kre twice a q say dipole moment p ka mana ni p equal to twice a q ni twice a q adu iba ta ga di the twice a q like sim hota dipole moment p can be replaced. Then this would be k twice k, then p x divided by x square plus a square whole square. Then obviously when you put the value of the dipole Coulomb's constant k, this should be how much then? E is equal to 1 by 4 pi epsilon naught twice px divided by x square minus a square whole square time. So this is the expression for electric field at the axial point of the dipole. Then just simplification masani sidi yam kaina aruba thabak nate. But in case of the dipole, electric dipole case when the length of the dipole is very small, say see the dipole in a minor yam tail say dipole twice AC a few centimeters, 1 or 2 centimeters twice AC. But if you take the point P at a large distance, point P is in a kayumba, X C kayumba large distance 50 meters, what will happen? Centimeters meters compare to x square 50 square the obviously it will be large. Then twice AC twice A 2 can 1 centimeter A 0.5 centimeter. When you convert it into meter again, there will be another 2 zeros here. Smile learning meter smile learning. 100 divide out that. Aduna 0.05 meter length. And this square of and then this should be obviously 0.0025. When you compare this, when x is very much greater than a, x square becomes very much larger than a square. Then under this condition, this a square term can be neglected. Okay, then aduna a square term is going to neglect of the target. Let us put the condition now. If x is very much greater than a, then a square term is negligible. Negligible what? A square is target. A square is 2 into 2. This would be how much? 4 direct. Then 1x, and this x, when you cancel it becomes 3. Then 2 is constant, p is constant, 4 pi epsilon naught is constant. Then what can you say? This electric field is inversely proportional to the cube of the distance. Right. So in case of electric field due to a dipole at the axial point, it is inversely proportional to the cube of the distance of separation. However, in case of the point charge, it was inversely proportional to square of the distance. So this gives the final expression, which shows that electric field due to a dipole at an axial point varies inversely with the cube of the distance of separation.